DC point of view. Okay, so DC means direct current, meaning that current only travels one direction. Okay, so it only takes the path from negative to positive. However, in the AC world, that changes up. So AC stands for alternating current. So why do we call it alternating current? Well, that's because current doesn't travel one direction all of the time. Okay, so you should have had this in previous semesters. However, I'm just doing a little video reviewing back over some of the terminology that you'll see in solid state that refers or that's kind of looking back on the AC world, just a refresher. So first, AC, remember, stands for alternating current. All right, so down here, this is going to be our AC waveform symbol. So anytime you see this symbol, a circle with a sine wave in it, which this is what a sine wave is, that is indicating that that is an AC source connected to that circuit. So a couple of really important things you need to know about how AC works. So I'm going to be referring back to this little picture here of the sine wave ever so often. So one of the most common waveforms that you'll see in AC is what we refer to as the sine wave, okay, or sinusoidal wave. But we just shorten that to sine wave. And this is created by some kind of rotating device somewhere upstream, okay? So all of your receptacles in your house, anything that an alternator is, or an alternator is being used to produce that AC, it is in alternating form. Because remember, AC is actually made by some rotating machine. So as it rotates around the poles and induces a voltage, you're seeing it go positive and then it goes in the other direction, okay? So you may remember back to the AC/DC machines class and we talked about how AC was actually generated. All right, so that plays a very important piece in how diodes actually operate. So bringing in diodes into the AC world, one of the biggest uses of this is for what we call rectification. And rectification just simply means changing. So diodes in the AC or the alternating current world are used to basically take your AC signal and convert it to a DC signal. Because remember, a diode will actually block current when you're in reverse bias. So it's only allowing current to flow one direction. So you're taking this alternating current and then you're sending it one way only, which makes it DC, okay? But more on that later down the road. First, we want to talk a little bit about how AC actually works, okay? So if you look, we can label this sine wave as positive and negative. So we have a peak voltage and a peak voltage. So jump down here. So peak voltage means that that is the measurement of that sine wave from 0 volts to either max negative or max positive. So if I'm measuring that waveform from this 0 volt reference line, from here to here would be the maximum peak voltage in the positive direction. And then from here to here, from 0 volt reference to here would be the maximum negative peak voltage. So peak voltage is just taking it from 0 volt reference to either positive or 0 volt reference to negative. Peak to peak is the entire span of that waveform. So it's the waveform from negative to positive. So I drew these arrows to kind of help out here. So a peak voltage reading would be from 0 volts to positive. A peak to peak measurement would be the entire span. So it's from the negative peak all the way to the positive peak. So I kind of threw these conversions up here. So if we had a 15 volt peak to peak voltage, that means that 15 volts is from positive all the way down to negative. So that means that if we measured it from a peak standpoint, it would be approximately half of the peak to peak. Okay? And then vice versa. If we had a 15 volt peak, so that means from 0 volt reference to here we measured 15, the peak to peak would be 30 volts. So peak is approximately half of peak to peak, and peak to peak is approximately double the peak. Okay, so that's all you have to remember. So remember a couple of other terms that we will be using pretty frequently, and that is frequency and cycle. So remember, frequency is the number of cycles per second, and that a cycle is one complete 360-degree rotation of that waveform. So for instance, I start out at 0, at 90 degrees I'm here, at 180 degrees I'm here, at 270 degrees I'm here, and then at 360 degrees I'm back to 0. Okay, so this waveform right here is one cycle. That is one complete 360-degree rotation. So ever how many of these that we have in a 1 second time frame is what we would refer to as frequency. Now frequency can actually get a little more broad, and it's just the number of cycles in a given time. However, generally we measure that time within a second. So for instance, if you're a receptacle in your house or somewhere upstream when we're generating that AC at 60 cycles per second, because the general frequency in the US is going to be 60 hertz. So remember, frequency is measured in hertz. So if your receptacle is 60 hertz, that means that you are actually getting 60 cycles per second. That means that machine is moving fast enough to make 60 complete rotations in 1 second. So that's how we get our frequency. Okay, so frequency plays a big part in the AC world. Okay, so back over here to the AC, let's talk a little bit about how this source would actually work in a circuit. So we have in a circuit what we call the upswing and the downswing. This is our upswing. This is our downswing. Okay, so I'm going to erase some of this just so we have a good, clear view of our waveform. All right, so here's our waveform. 1 cycle. Okay, so this is our upswing, this is our downswing. Okay, so on an AC source, when we are going in the upswing, that means that we are traveling in the positive direction. When we are in our downswing, we are traveling in the negative direction. So this is where it swaps polarity. AC does not have a defined polarity. It's constantly swapping. Every half cycle, your polarity swaps. So on the upswing, this would be your polarity, because we are traveling in the positive direction. Because if a circuit was hooked up to this, current's going to travel this way. Now, what happens on the other half cycle? Polarity swaps. Okay? That's where we get that alternating current, because polarity is constantly swapping. So remember, the upswing, this is my polarity, positive on top, negative on bottom. And on the downswing, negative on top, positive on the bottom. Okay? So that's very important to remember that. So upswing, positive on the top, downswing, positives on the bottom. Okay? That's very important to remember that. Okay? So if you got to back this up and make notes, please do. So this is the upswing polarity. Okay? And then this is the downswing polarity. Okay? All right, so very important to remember, because when we start doing our diode circuits and observing our outputs and what the waveform looks like, you have to know what the upswing and the downswing looks like. Okay? So that's all for this video. So just a recap: AC, alternating current. This is our source, okay? This is what our source looks like in AC. Remember your upswing and your downswing. Peak voltage is just measuring from 0 volt reference to positive or 0 volt reference to negative. Peak to peak is the entire span of the waveform from positive to negative. Frequency is the number of cycles per second measured in hertz, and cycle is one complete 360-degree rotation. Okay? So, if you're good with that, we're going to move into the next video, which is going to be our first AC diode circuit. Okay? So we're going to start out relatively easy, and then we're going to work our way up to more advanced circuits later in the week. All right, so if you have any questions, please let me know, and stay tuned for the next video.